In our previous video, we looked at the domain of the inverse is the same as the range of the original. So remember, inverse is defined as f neg 1x, or f neg 1 here, and original is f. And also the range of the inverse is the same as the domain of the original function. And the graph of the inverse is obtained by reflecting the graph of the original through the line y equals x. And that was really much the theme of the last couple of videos we looked at. Here's a bit of extra stuff. If f function crosses the line at y equals x at any point, then f and f minus 1 will intersect at that point. So let's look at that. Consider, that's a bit bigger. Consider the function f of x equals 1 over x plus 2. State whether or not it is a one-to-one function, and hence determine if the inverse exists. If the inverse exists on the same set of axes, sketch f of x, its inverse, and the line y equals x. Okay, so let's just revisit what a one-to-one function is. We might look at this one here. It's 1 over y equals 1 over x plus 2. So if we look at the general look of that graph, if I just draw it roughly down here, the graph will be a hyperbola which has been shifted to the left 2 places. So we'll get an asymptote at negative 2, so we're going to have something like that. Won't cross the axis, of course, and that as well. Okay, so that's just a rough sketch. Now, remember our definition of one-to-one functions is that 1x has one and only one corresponding y. And it doesn't matter what point we choose on the hyperbola, that x will only have one y. That x will only have one y. So it's a one-to-one function. Okay, and thing for one-to-one functions, the inverse always exists, because if you swap those one-to-ones over, you've still got a function. It's when we've got one to many or many to one is when we get into trouble. So it is a one-to-one function. Let's look at its inverse. Well, remember, to get inverse we can do it on the calculator or the longer way. We swap x and y over and we find y again. So I've swapped x and y over. I've swapped the places there of those two, and you can do that little manoeuvre. I think I've mentioned this before. If a equals b over c, then c equals b over a. And swap those two over. So y plus 2 equals 1 over x, and to get y by itself, take the plus 2 over, and it becomes minus 2. So y equals 1 over x minus 2. So there's the original here, and there's the inverse there, f minus 1x. So I've graphed them on the same set of axes, and if you look at which one's which, the 1 over x minus 2 is the normal hyperbola shifted to the left 2 places. So that's the red graph, okay, because y equals 1 over x plus 2. The blue graph is the inverse. That's the 1 over x minus 2 that's been shifted down 2 places. So that's y equals 1 over x minus 2. And you can see there, I've also graphed y equals x. As I pointed out in the notes before, where those graphs cross y equals x is also where they intersect. Okay, because if you swap x and y over at that point, you'll get the same point there. So those crossing over points are the intersection points. And we know that lines will intersect when they have two common sets of points. Use the calculator to find the points of intersection. So I've done that here. This is a screenshot from the TI Inspire. So there are two graphs drawn there, and sure enough, we've got our intersection points there and also there for those two graphs. Try that yourself. Graph up the two functions, the original and the inverse, and find those intersection points. Alright, now this is the tricky part of this little unit on inverses coming up. State the largest domain of f of x so that f minus 1x exists. Now we talked before about, in the last question, how in a one-to-one function the inverse exists. Okay, here it's a different story because we no longer have a one-to-one function. This is what we call a many-to-one function. So in other words, if we look at an x value, say negative 5 here, negative 5 has actually got, sorry, not negative 5. If we look at the y value of 2, it's actually got two x values. Okay, so we've got negative 5, comma 2, and also it's around about negative 2, comma 2. Okay, so that y value of 2 has got two possible x values. So what happens is, if we get the inverse here, let's write those down again, so I shouldn't have taken them off. Negative 5, 2, and negative 2, 2. What happens is, if we get the inverses of those points, we end up getting 2, negative 5, and 2, negative 2. And that breaks the laws of our function, because in a function, our x can only have one y value. Here we've got x having two y values. So whilst our original is a function, it's fine. It has that, it passes the vertical line test. The inverse of this will be something like this and won't pass the vertical line test. So let's revisit the question. State the largest domain of the original function so that f minus 1 exists. In its current form, it doesn't have an inverse function. It has an inverse, but it's not a function. I'll show you what I mean. There it is. Contrast them. Original, inverse. Original, inverse. As you can see, the inverse is not a function. It does not pass our vertical line test. Here we go. If we put a vertical line down, it crosses it twice, so it's not a function. Alright, but if we restrict the domain here in the original, okay, at the moment our domain is R. Okay, our domain is all the real values. If I restrict that domain though, I can get my inverse to a situation where it's a function. This is where the iPad comes in handy for this, because I can demonstrate how this works. Alright, there's two ways in which I can create a function for the inverse, and I might start with the actual inverse. So here we go. So what I'm going to do is I'm going to rub out half of this. Okay, if I do that, I actually end up with a function. What I've got left is a function. It satisfies the vertical line test. Alright? Now, if I rub out that side on my inverse, I've got to rub out half also of my original. Okay, and the half that I would rub out would be the half that corresponds to that. So I would rub out this here. Okay, so I've restricted the domain there of my original. Now if I look at my inverse, okay, and my original, they're still both functions. That is now a function. Before, okay, if I undo what I did, it's not a function, it's now a function. Okay, I've had to restrict the domain of the original. The original domain here was real numbers. If I restrict it to that, it means my inverse is that. Now my inverse is a function. Hope this is making sense. Alright, so the domain here, okay, is going to be, it says state the largest domain. We'll get to that in a minute. But my domain here now is, whoops, negative 3 to negative infinity. If I restrict my domain to that, my inverse is a function. Alright, let's have a look though. And we might just have to draw, just bear with me for a moment. I'm just going to draw for a moment my original back in again here, which I think it went through 9, didn't it? So that was my original function. I'll draw it back again. Okay. Now, and I'll get my inverse back. So that's one way I can do it. Now the other way you might have worked out that I can do it is if I rub this out. Okay. Therefore, over here, in my inverse, I would rub this out. And voila, I've got a function again. I've restricted the domain of that, so it only goes from -3 onwards. Okay. In fact, just bear with me. I made a mistake here with that. I should have had the negative infinity first. So just sorry about that. I hope you picked that up, and I hope that doesn't confuse you. Okay, so that was the previous domain. All right, sorry. So back to this. So I've restricted that to that. So I've now got a function, passes the vertical line test. All good. So what's my domain this time? This time my domain is from -3 up to infinity. Okay, so my largest domain there, that's what we're after here, the largest domain, is the second one. Okay, because it's from -3 to infinity. Okay, going that way. So it's my largest domain. So just repeating there, my original function, okay, if I go back here, my original function, its inverse was not a function. Okay, it did not exist. Okay, the inverse function did not exist. It wasn't until I was able to restrict the domain of the original, then I was able to get, I was able to get an inverse that actually existed by restricting the domain. Let's try another one. Okay, this is a bit of a harder one. State the largest domain of f of x so that f minus 1 exists. So there's my original function, and the key points here, remember, are -6, 0. I've got -4, 4. I've got -2, 0, and I've got 0, 3. Okay, I've drawn those very well. So let's go one by one. So -6, 0 becomes 0, -6. So that's that one. -4, 4 becomes 4, -4. -2, 0 becomes 0, -2. And 0, 3 becomes 3, 0. And I draw the graph with the same shape as the original. So there's my inverse. Now once again, my inverse is not my original is not a one-to-one function. Okay, it's a many-to-one. Because y values have more than one x value. So when that happens, when you get your inverse, it doesn't pass the vertical line test. Okay, it crosses it 2, 3 times. So it's not a function. So how are we going to make this a function? Okay, well, there's a couple of ways to do it. One way, and I'm going to start erasing here. One way is to erase to there. Okay. Now, if I erase to there, I've now created a function. It passes the vertical line test. So I do that there. I've actually also got to do that here as well. Okay, so let's compare what I've rubbed out there to what I'm rubbing out here. Here I'm rubbing out this part of the function, so to there. Okay, compare them again. There they are. Alright, so to get a function in my inverse, I had to rub all of that out. Okay, so look at the domain there. The domain there would be, I'll get it right this time, -infinity to -4. Okay, there we go. Now let's go back to here. That's one way in which I can create an inverse which is a function. The second way I can do it is to erase this part of the graph. Now I've got a function that passes the vertical line test. Nice and simply. Now to do that, if I do that, I've got to go back to my original. Okay, I'll just reinstate. Sorry about this. There we go. Oops. Reinstate that. So look, here's my function working nicely. So what do I rub out here? I've got to rub out this part now. Here. What I've got left corresponds with what I've got on my inverse. What's the domain there? The domain this time is -2 and square bracket to infinity. So that's my largest possible domain. The other one is not as large as that one. So there's my answer. Largest domain is -2. Now, the iPad was great for this because I was able to, to rub out and erase things. So what you've got to do is create a function. So first of all, you draw your original function, you draw the inverse. If the inverse is not a function, then you've got to look at, well, how do I create a function? And if I rub off a section of the graph here, like I did, okay, what do I have to rub off on the original? You rub off the identical part, that leaves you with a domain that gives you a function in the inverse. All right, so next lesson, we're going to work on exercise 5C. So I might put some questions down here. Okay, so exercise 5C, there's the questions I'd like you to do. Have fun.